Hello students, we already know about integration. We have some standard results to follow to solve the integrations. For example, x raised to power n dx is equals to x raised to power n plus 1 upon n plus 1 plus c. Integration of sine of x dx is equals to minus cos of x plus c. Okay, integration of e raised to power x dx is equals to e raised to power x plus c, and so on. Many more results. But what if we have an integration of kind sine of e raised to power x into e raised to power x dx? How can we solve that? Do we have any kind of standard result which can solve this integration? Answer is no. We don't have any kind of standard results. So what we have to do is we have to find the methodology that can solve this kind of integration, and our methodology is integration by substitution. As the name suggests, the substitution, that is, we have to substitute the function with, or you can say a proper function, with some another variable such that our given integration can be reduced to some standard form. Some standard form. Okay. And the question is, how can we do that? How can we find that proper function? So let's take some examples to overcome this problem. First, let's just elaborate this definition in mathematical terms. We can have that f of phi of x into phi dash of x dx. That kind of function. If we have that kind of function, then we can use the method of substitution. And this function says that if we have a function of another function, which is, let's say, phi of x, and we have in multiply the derivative of that function, phi dash of x dx, then what we can do is we can just substitute phi of x with some another variable t, such that our dt is phi dash of x dx. That is the function sitting over here. And our integration will reduced to f of t dt, which is much simpler integration than this. Okay, let's try to solve an example. Let's consider that example only that we have seen in our previous video. Right, so here we have sine of e raised to power x, that is a function and another a function, and here we have the derivative of that function, because we already know that the derivative of e raised to power x is e raised to power x, right? So what we can consider is, we can consider our e raised to power x as phi of x, and this as phi dash of x dx. So substitute substitute phi of x is equals to e raised to power x equals to t, such that dt will becomes e raised to power x dx, and our integration will becomes integration of sine of t dt. And you can already see that we have our standard result to solve this integration as minus cos of t plus c, and again substitute the value of t. We get minus cos of e raised to power x plus c as our final result. Okay students, let's understand this concept with some another example also. Our next example is integration of sine cube x plus 5 sine square x plus 2 sine x plus 3 and multiplied by cos of x dx, right? So just observe that function. What we have here, we have sine of x and its derivative sitting with dx. So just simply substitute phi of x is equals to sine of x is equals to t, such that our dt will becomes cos of x dx, right? So our new integration will becomes integration of t cube plus 5t square plus 2t plus 3 dt, right? And just simply take this integration one by one. We have t cube dt plus 5 of t square dt plus 2 of integration of t dt plus 3 into integration of dt, and apply the formula integration of x raised to power n dx is equals to x raised to power n plus 1 over n plus 1 plus c, right? So what we will get is t raised to power 3 plus 1 over 3 plus 1 plus 5 into t raised to power 2 plus 1 divided by 2 plus 1 plus 2 into t raised to power 1 plus 1 divided by 1 plus 1 plus 3t. Okay, so this will becomes t raised to power 4 by 4 plus 5 t raised to power 3 by 3 plus 2 t raised to power square by 2 plus 3t. Okay, so again it can be simplified as t raised to power 4 by 4 plus 5 by 3t cube plus t square plus 3t plus c. If we write c, okay, now let's just put the value of t, which is sine of x, that is sine 4x by 4 plus 5 by 3 sine of cube x plus sine square x plus 3 sine of x plus c, and this is our final result. Simple. You can see that by using this method of substitution, which says substitute the value of phi of x such that our integration can be reduced to the simple form, we can just have our integration results, which can be derived simply by following the rule of substitution. Okay.